of 2 pi over 3 is negative root 3. After counting around my circle 2 pi over 3 radians in angle rotation, I drew a reference triangle and used the reference angle to do opposite over adjacent to get negative root 3. Sine theta equals negative root 3 over 2. This time I'm looking for theta, which means I'm looking for the angles in which sine theta equals negative root 3 over 2. So if I know sine is the y-coordinate, then I'm looking around my unit circle to find out where the y-coordinate would be negative root 3 over 2. So it has to be in those bottom two quadrants, and it happens at the thirds down there. So I just counted around to get 4 pi over 3 and 5 pi over 3 is the theta values where sine theta equals negative root 3 over 2. Last one, cosine of negative 210 degrees. Okay, so first I counted around my circle, got my negative 210 degrees on there, went clockwise this time, drew my reference triangle, and did adjacent over hypotenuse to get negative root 3 over 2 for cosine of negative 210 degrees.
You know what sounds really good right now? Waffles. Okay, let's see. What do I need? I have my mix, I've got my cup of milk, okay? I got 1 egg, yeah, no problem. Okay, a tablespoon, okay, a tablespoon. All right, let's see. Oh no, I don't have a tablespoon. All I have is a teaspoon. Okay, my math skills will survive here. The recipe calls for 4 tablespoons. So if I use dimensional analysis, I know that 3 teaspoons fit into 1 tablespoon. So if I multiply across, I can divide out my tablespoon measurement and get 12 teaspoons. That's what I need. So we got this. Waffles, exactly what I needed. I wonder if I could use this unit conversion thing to convert from radians and degrees.
The ones we know, of course, 30 degrees is pi 6, 45 degrees pi fourths, and 60 degrees is pi thirds. We know, too, that a full circle rotation gives me 2 pi radians and a half circle is pi radians. So this is great. What about angles that we do not know? Then we need to have another method. So let's use the degrees and radians that we have on the ones we know to learn what to do. If I'm given 30 degrees, then I need to somehow convert this to radians. So I need a conversion factor. Well, we know that a half circle rotation is pi radians, and of course, in degrees, a half circle is 180 degrees. So there's my conversion factor. 30 degrees times, now think about this, I want the degrees to go away. So I'm going to put the 180 degrees on the bottom and pi on the top, and we know that pi radians is the same angle measure as 180 degrees. The degrees divide out, and we are given 30 pi over 180, which reduces to pi 6. What about going the other direction? Say I start with pi fourths. Well, this time I'm still going to use the conversion factor of 180 equals pi, but I want pi radians to go away, and I want to keep degrees. So degrees will go on top, pi will go on bottom. 180 degrees is the same as pi radians in rotation. Pi's divide out. 180 divided by 4 is 45 degrees. So once again, conversion factor, you're either trying to get rid of degrees, multiply by pi over 180, or rid of radians, multiply by 180 degrees over pi. Try A through D and then come back.
Okay, let's check A through D. So A, converting negative 3 pi over 4 radians into 135 degrees. B, converting 27 degrees into 3 pi over 20 radians. C, converting 2 pi radians to 72 degrees. D, 225 degrees converts to 5 pi over 4 radians. Okay, now for E and F. They're a little bit different. Okay, so E says 2 radians, so we're going to need to convert to degrees, but how weird is this to see radians without pi? So just a reminder, remember radians came from radiuses around a circle, so they don't have to include pi. Like in our first video, we saw that 1, 2, 3, and a little bit more radiuses fit around the circle. And then we started calling those radiuses radians, so it's okay to just have 1 or 2 or 5 radians. So if we were going to make a guess at where 2 radians would land, we know that pi radians fit around a semicircle? Well, pi is 3.14-ish. So we could use that to estimate where 2 radians lands. We could say like 1 radian hits about here, and then 2 radians would hit about here. That way we're finishing with about 3 radians at the semicircle. All this is to say that radians don't have to include pi. So here, when I start converting from radians to degrees, you're going to see me write out rad for radians so that I don't forget that that is 2 radians. This way I'm multiplying by 180 degrees over pi radians. So now my radian measurement divides out, and pi does stay behind this time. It didn't divide away. So 2 times 180 would be 360 degrees divided by pi though. So my exact angle measurement would be 360 over pi degrees. So we can also write an approximate version of this, which comes out to be about 114.592 degrees. So if we know about 3.14 radians fit around a semicircle, and we were saying before that 2 radians would fit about here, then we can see that 114 degrees is right about where our guess at 2 radians was. As we move along to F, we see 4.7 written. So is this degrees or radians? Well, if you think about all our other radian measurements, especially in this example, they had pi in them and they didn't have the rad written for radian. They were assumed to be radian. So it would be a fair assumption to say that 4.7 is radians rather than degrees. We're always going to see that degree measurement on degrees. Okay, why don't you pause the video here and try to do F on your own and then come back and check. So to convert radians to degrees here, I need to multiply by 180 degrees over pi radians, divide out my radians, and get 846 over pi degrees for my exact answer, or 269.290 for my approximate.